sled. So I draw the sled first. Sorry, my drawing is so bad. All right, so we're going to draw the free body diagram first of the sled. And remember, he's pushing down at an angle, theta. What was it? Okay, so here's the sled. Here's your normal force. Here's your force of gravity. This is the angle that he's pushing down. So this is your applied force. And then I have my force of friction. All right, so now we have all of our forces. Next thing we got to do is figure out our components. So we're going to kind of break this down here. So it's only moving, the force being applied on the sled is in the y direction. It's kind of tricky. Well, whenever you have this applied force going down in this direction like this, it's going to exist on the y. Okay? So whenever it's going down like this, we're going to have an applied force in the y direction. If it's going directly to the right, then we would break it down into its x component, but it's not. It's going down in this diagonal direction, so just remember that that's an applied force in the y. So then I'm going to use my basic kind of trig here. And then my theta is here, okay? So that's my theta. And I don't think we even need that. We don't need the actual value for theta because they're essentially just wanting the formula. Okay, so again, draw your free body diagram. Whenever you get, whenever you have this kind of angled applied force, that's going to tell us that it's in the y direction. What do we do? So also, I can just kind of break it down for you, and I'll give this to you guys on any sort of assessment. You're going to have your vertical component, which is typically going to be y equals f sine theta, and then your horizontal component is going to be f of x equals f cosine theta. And this is, I just kind of did the trig for you guys, but you can also solve that by looking at, creating that right triangle and using SOHCAHTOA from there. Okay, so the next thing we have to look at are the forces being applied in total, okay? So since we're looking at it from the y direction, so we're going to have what forces? Force of friction, we're not going to worry about that because that's only in the x direction. But again, because this is in that diagonal, we're going to look at the y. So this is the y, so f of n, f of x, f of ay, okay? So then I'm going to have the summation of my forces is equal to mass times my acceleration. We can start here, or you can start wherever you want. That's positive, it's going up, so it's going to be f of n. This is going down, so it's minus f of g. And this one on the y direction is also going down, so it's going to be minus f of a in the y direction. But this is where it gets a little tricky. You got to make sure you use this because we're breaking it down into its vectors. Okay, so it's going to be f of a of y sine theta is equal to 0, okay? It's equal to 0 because he's just pushing down. If you read the question, he's just pushing down on the mass across the rough surface, applying the force. It's not moving anywhere in the y direction, okay? So he's not moving, he's not accelerating in the y direction, so just kind of just be cautious of that. So this is going to be 0. So again, it's not moving in the y direction. It's not moving up and down or anything. And essentially, all they're asking is to solve for the normal force that's being applied to the sled. So then just using kind of basic algebra, right? F of n is going to be equal to this here becomes, you can leave it as f of g, but you'll see it oftentimes change to F m mass times your gravitational constant, plus this here, my F of AY sine theta. And again, just because of the algebra, right, we had to switch the sign. We had to switch the sign here as well. So when we break it down, this is our formula. And again, if the trig is a little, I mean, I know you guys know trig, you guys are in calculus, but if the trig is a little confusing, I can just add these to it too. I don't think it's confusing. I just want you guys to remember to use it. So if it's already there for you, you'll remember to use it. And also, this is given on the AP test. They'll break down the vectors for you. And just look at the vector equation sheet, and that'll be there for you. I hope that helps.